Amazing. Thanks so much, Eric. And thanks, Fraser Basin Council, for having us today. We're really excited to explore climate risks and adaptation and mitigation for renewable energy systems. Today, we're going to look at climate exposures and try to do our best to define what that looks like in the context of insurance. Then we'll also get into insurance coverage from a defined perspective, what it is, how it functions, what it is not, which is more important, I would argue, and some of the key terms and concepts. And then we'll look at outlook and planning, the life cycle, trends over time, and what you can do now to prepare yourselves for the future. So first, we're going to try and do our best to explain climate exposures so that everyone can be on the same page as it relates to where we're starting from and where we're going to from a natural catastrophe and what the site characteristics really are. So I'm going to step back and go through what the site characteristics are. You'll note that we've included wind here, although the majority of this presentation is focused on biomass and solar. We included wind because there's a lot of wind happening in BC, and there's a lot of critical infrastructure that relates to it, as well as solar and biomass. It also helps for context. When we look at these three things, starting with solar, you'll notice that it's relatively compact, especially in the context of BC. When we look to Alberta, there's a lot of mega projects that are spread across hundreds of acres. But in BC, we see a lot smaller projects, a lot of rooftop projects, and they're relatively compact. They're made up of panels, racking inverters, power lines, and transformers. When we move into biomass, it's very concentrated. It's a small area, but high values and made up of feedstock delivery and storage, power gen equipment, piping, power lines, and transformers. And you'll notice a theme here with transformers. Wind farms, as a contrast, although you've got, towers, power lines, and transformers, and each tower can be fairly high value, especially these days. I will say that they're distributed. So you'll have a turbine and then another kilometer or a few, another turbine, and they're not concentrated. So in the context of natural catastrophe, the way we think about it, and the reason I'm mentioning it is that when you have a natural catastrophe like wildfire or even hail or wind, if you have a concentrated site, it's more likely that you'll lose the entirety of the site as opposed to a piece of it. Moving into what the critical infrastructure is, substations and main power transformers are the most critical piece of equipment. You'll note there's a call out in the bottom left regarding the substation and main power transformer being a choke point. And it is certainly something that the insurance industry is focusing on. If you lose the main power transformer, it shut down the whole project. And often lead times are quite lengthy. 12 months seems to be around the minimum. And in some cases, it can be out to 5 years if it's a large transformer or substation with bespoke equipment. Owned lines to the interconnection, this is typically your responsibility. Those transmission and distribution lines form part of your project, and they're certainly exposed to climate perils, especially if there's long length to them. The non-owned lines to the first substation also pose a threat. Not your property, so you don't own it, but a disruption here can certainly impact your revenue. So if there's a loss between your site and the first non-owned substation, especially if it's related to climate, we sometimes see more so in BC, long lengths of transmission and distribution infrastructure. And a lot of that is exposed in the context of BC to wildfire. Next, Eric, please. So what are the risks? We spend a lot of time talking to our clients about what those natural catastrophes or climate-related risks look like and how they're defined within the context of insurance policies. You'll note that we have high, moderate, and low tags here. This has been flagged in the context of projects within BC. Wildfire seems to be the most consistently high hazard that we're facing in BC, although followed pretty closely by flood. Wildfire causes catastrophic property damage. Oftentimes, it can pose a liability exposure as if it's your infrastructure that causes that loss. You can certainly be held liable. And of course, where solar is concerned, if there's ash or thick smoke, it can cause an efficiency loss. And that is something typically not insured within the confines of a typical property policy, can be insured elsewhere. Not often do we see people purchase insurance for it, but certainly a risk. And of course, feedstock loss. If you lose forestry or any other inputs to your biomass facility, then you don't have any facility to run. Flood, same idea as wildfire with catastrophic loss potential. Overland and watercourse exposures, if it's close to a river or you're in areas of high rainfall quickly. It's important to assess the exposures and, of course, single points of failure. It's also important to note that the flood zones are changing, and we do recommend mapping those consistently, but we'll get into some of those things next. Hail is lower in BC. Alberta is where we see the most consistent exposure to hail, which relates to solar very specifically. There's lots of mitigations that you can input if you are concerned about hail, but it is less common in Western Canada. Excessive heat is something to be concerned about, likely more related to a wildfire heat exposure. However, it can move into drought. That has more of a personnel risk. It can increase wear and tear on equipment, which isn't something typically insurable. It can raise feedstock storage fire risk and spontaneous combustion of feedstock risk. On the wind and storm side, it's less of an exposure in BC unless you're coastal, in which case, of course, you have exposure to storm. Most of that has to do with the main power transformers and the transmission distribution lines. Freeze and snow is also lower in BC, although if you get into mountainous locations, you may see higher snowfall, in which case you need to design to that exposure. Where wind is concerned, again, more of a concern, I would argue, in Eastern Canada, where we see ice throw as a liability issue from the blades, and of course can cause site access issues and efficiency losses. Lightning is a higher hazard in BC. The strike risk for turbines. Biggest exposure for biomass and solar would be the transformers and other electrical equipment. And the frequency and severity can certainly drive costs on the insurance side. And drought will impact degradation of the feedstock, availability of water, and of course can also raise feedstock storage fire risk. Some of the things we're not talking about today, but we wanted to flag so that everyone was on the same page as it relates to the biggest exposures in power generation equipment from an insurable perspective. Earthquake is not considered a climate risk. It is considered a natural catastrophe risk and often subject to the same bucket within the insurance policies. Of course, significant risk in BC, but we view it as unaffected by climate change for the most part. Equipment breakdown is likely the single largest failure point, exposure for the critical equipment that is outside of a climate exposure and covered by insurance, and then structure fire. So non-wildfire exposures, think electrical, operational, they are covered, but also not driven by climate change. So today, what we're talking about is a little bit different than what we have seen the other webinars that Recap has done. We're going to talk a lot about what the insurance industry is looking for and looking at in the context of climate and adaptation and mitigation for renewable energy projects. We'll be focusing on the design phase, which encompasses the development phase of projects, factors and safeguards that you can include within the project design, and things to contemplate before you get to the build phase. Once things are built, the ongoing operations will be contemplated as it relates to the impacts of climate, ongoing and recurring inspections, testing, maintenance, and of course, planning protocols. Wildfire. So this is the first para we're going to get into a little bit more of a deeper dive on. Certainly something that we've seen an increase in both frequency and severity across the country in BC, but also in places that we hadn't anticipated it before. And the severity has certainly increased. In the development and the design phase, might seem like you'd expect this to be contemplated. Sometimes I think it's not reviewed in as much depth as it should be, which is the catastrophe mapping or natural catastrophe mapping. Using available hazard maps that include wildfire and have good mapping history to understand historical and projected exposures is really important. From a personnel perspective, understanding evacuation routes and, of course, proximity to first responders in the event that there is either an external fire or internal fire that may lead to a wildfire. In the design phase, making sure that there are adequate setbacks and fire breaks. In the context of solar arrays, often we see roadways as natural fire breaks that can be designed and incorporated within the project without much thought, but making sure that they're wide enough and of a material that is not going to carry the fire is incredibly important. We do know that fire can jump if there is anything that's combustible nearby and the wind conditions are in a certain way, it can exceed 20 feet. So really important to contemplate that. Fire detection and suppression systems equally as important in the context of biomass and biogas facilities, especially the fire suppression systems. Making sure that there's access to water. So in the design phase and site selection phase, making sure that there is access to adequate water supply. Most of these facilities are rural, and so there are no hydrants nearby, making sure that you have access either to a water reservoir or pumper trucks with enough personnel to make sure there's enough water to put out a fire. And automatic fire suppression for biomass facilities is key. On the ongoing operations side, making sure that you have an evacuation plan and an adequate emergency response plan, even a wildfire response plan specifically. Detailed plans are key. You want to make sure that they're shared with the local authorities, first responders. There's lots of bits and pieces that are included within these plans, but making sure that they're revisited. So making a plan and sticking it on a shelf and not talking about it for the life of a project isn't the most useful way to go about it. We suggest that something that's reviewed consistently, that anybody who's noted within that manual as having an action item is aware that they are noted in there, that they have an action item, they know what to do, and that there's a backup in the event of an emergency. And testing these things out on an annual basis is also recommended so that everybody knows what to do. Also, making sure that the first responders, there's often a lot of turnover within the first responders. So making sure that they're aware of what the safety plan or the emergency response plan is also key. And it's not much more necessarily than just an email to make sure that people are aware of it and that they're doing their own training internally and visiting, having your local responders come to site on an annual basis is also a good idea so that they know what they might be walking into, where things are, and what to do and who's responsible for what. Site monitoring and sensor networks with defined responses. So again, back to it's nice to have something in paper format that you stick on a shelf, but if you don't know what to do or what happens, it's useless. May as well be a paperweight. Site monitoring and sensor networks are the same thing. If there's an alarm going off, but it doesn't go to anywhere or anybody for an action, then it doesn't matter. Again, it may as well be a paperweight. So understanding what those response protocols are, the insurance industry will pay particular attention to understanding who's responsible for those alarms, where does it go, and what is the response and the response time. Vegetation management is another one that's really important from an ongoing maintenance perspective. When we're talking about solar, and I've seen this time and time again, where people are mowing just around the array with like a 10-foot fire break, and underneath it, there may be sheep included in that plan, but they're not putting enough of a buffer between the array and the externalities that could pose a fire risk. So making sure that you have an adequate fire break is really important and that your operations and maintenance folks understand what the expectation is within that vegetation management plan. If your site causes a wildfire, this is certainly something that PG&E got caught up in causing a wildfire in California. It cost them. So making sure that vegetation management under your T&D lines is maintained is key as well. From a flood perspective, this is really important in the context of BC as well. We've seen tons of flooding. Most of that impact in our world was on hydro facilities, admittedly, but as more and more facilities, solar and biomass come online, the exposure is certainly increasing. In the design phase, back to site selection, you're going to hear a lot of that from us is making sure that when you're looking at a site, before you sign a lease, if there's a land lease involved, before you spend too much money on a site, make sure you're mapping it and make sure that whatever flood mapping is available is something that you can either design to mitigate any sort of loss or perhaps move site. Drainage design and site grading, berms are useful. Definitely vegetation planting is key on the solar side. Engineered drainage and elevating equipment is key to manage overland and watercourse flooding and the erosion control as well. We've seen a handful of claims coming out of Ontario. I do think we have learned a lot of lessons in the design of solar farms from the feed-in tariff days, but there were a few liability claims for silt moving into farmers' ponds. And the definition of a pollution is introducing something to the natural environment that was not there previously. That includes different dirt. So understanding what those implications can be, because you can be held liable if there's an overland flood and there's an erosion of a specific dirt that contaminates somebody else's land or water, you will be responsible to clean it up. And those expenses are high. In order to avoid flood issues with transformers and other critical equipment, raising the components and ensuring you have building protection is key. Biomass equipment and feedstock, certainly the feedstock exposure of spontaneous combustion and moisture is real. So making sure that mindful of that. And then one thing you probably wouldn't really necessarily know is turbine doors. Those turbine tower doors, if they're at ground level and you're in a low-lying area, you can be flooded out and not have access to your turbine. You'll notice designs have changed over the last 10 years to have a few steps up to the door. Wasn't so not so long ago. And then on the ongoing operations, the emergency response planning, making sure you're monitoring floods, looking for early warning triggers and recovery procedures. What does that look like? And making sure that plan is practiced and followed. And then, of course, recovery planning. So pre-plan for post-flood equipment inspection, making sure there's a process in place for drying equipment as necessary, and then critical spares on hand if possible, if there is an exposure and there is no mitigation available. Making sure again of stormwater runoff and flooding of nearby bodies of water. It's not always just rising water, it can be overland flood as well, and protecting the single points of failure. Hail is a bit less of an issue here. As I mentioned, it's more of an Alberta issue, although I'm not sure if anyone here will be developing projects across the country. If you are, this is for you. Making sure, again, you're mapping it. We can't stress the mapping exercise enough. We do a ton of that for a lot of our clients and making sure they at least have a cursory view of what those exposures are. There are a few things that you can do if you are designing and putting panels in a hail-prone area. There are hail-resistant panels, although they do come at a cost. So making sure you understand what that cost is versus the exposure and whether you have a tracking system, because that will be very meaningful. The tracking systems are the most commonly used hail mitigation tool. These trackers can stow to a hail defensive position, which is one of the most key mitigations. And there's a race with the racking manufacturers to the steepest stow to avoid hail. Fun fact. On the ongoing operations, certainly continuous weather monitoring and a stow plan, but also checking your trackers to make sure that they stow appropriately. Most solar farms are across, 50 to 100 acres, give or take. There's lots of them. There's lots of moving parts if you're using trackers, making sure that you test them to make sure they actually stow in the event of a hail event. And then, of course, recovery planning. If you've got some spare panels, that's always useful. And of course, if there is hail damage, replace them as quickly as possible, as damaged panels lend themselves to hotspots. And if you have hail resistant panels, it can be a challenge to get them replaced through the normal channels of manufacturing, as they are not often available right off the shelf. Wind and storm mitigation, again, tracking systems come into play here. So making sure that you're designing from a cost perspective, that you understand what the cost is of that system. Wind stow is the opposite of hail stow. It'll tabletop in the event that there is a windstorm incoming and avoid as much of the wind damage as possible. And of course, making sure that you're engineering to the expected wind loading. Unexpected and gusty wind events can certainly cause nasty losses. Ongoing operations, again, testing your stow, making sure it consistently works, maintaining everything as necessary. They are moving parts, and then having critical spares as necessary. I will say, if you're in the coastal area, that because of salt air, you may lend yourselves to early degradation. But if you're inland, you can avoid that particular exposure. And then, of course, active weather tracking and escalation procedures from a storm monitoring perspective. Know what's coming as much as you can and do your best to plan accordingly. And having an emergency response plan is key. Although this is very solar heavy as opposed to biomass. Freeze and snow. On the design phase of where it relates to solar, again, back to tracking panels for snow dump. There's isophobic coatings available. The de-icing system within the wind turbines is really important to make sure that it's functional. Heat tracers on oil lines and critical equipment. You can also use it for solar panels to melt snow. Where we see the most critical, though, is if you're getting equipment from overseas, especially if the manufacturer is from a warmer climate, making sure that from a biomass perspective, that equipment is engineered and they understand that the operating conditions will be in sometimes very cold regions. We have seen losses where equipment has failed because it wasn't designed to the cold that it was intended to operate in. And that had resulted in a year and a half of downtime in litigation with the manufacturer, who also was the design engineer at the time. So making sure that that is well noted and that those equipment warranties are with manufacturers that understand what temperatures so that the threshold buffers within those equipment warranties reflect the operating conditions that that equipment will be operating in. And then, of course, on the solar racking side, we have seen our fair share of collapsed solar panels or solar arrays, I should say. And we generally recommend to engineer slightly higher than expected for snow and ice loads because we are seeing higher snow loads than anticipated, and that higher snow loads than have historically been met in those jurisdictions. So just making sure that your engineers are being diligent and perhaps a bit more conservative on that side, and that the racking manufacturers are also upholding those warranties and understand the conditions for which that array will operate. And then from an ongoing operations, understanding the freeze and snow response planning. If there's a lot of snow, you will be expected to clear that snow so that it does avoid the weight of ice and snow and a potential collapse. So understanding what that recovery planning looks like and testing and maintaining tracking equipment if it exists. We saw losses last spring in the Ontario market where we had a huge ice storm out here, and the ice was so thick and so heavy that it broke off the leading edge of a number of panels in 6 solar farms that we had on our as clients. It was something that we had never seen before and was definitely unexpected. I think that's an outlier event, but just something to note that anyone that had those heat tracers on their solar panels were able to melt ice enough that it didn't impact it in the same way. So just some things to consider. And when we're talking about wind turbines, ice throw is a liability issue and a property risk because in the event that there's ice and snow on your wind turbine, if it's not spinning and it stays, it can collapse your turbine. And if it's spinning and it throws the ice, it becomes a liability issue. So understanding where your setbacks need to be from roads and buildings, and understand what the personnel need to do if they're in the area. Lightning, we've seen our fair share of claims here too. and more frequent and severe lightning instances are certainly happening. So, in the design phase, making sure that you've got good lightning protection systems built into your facilities, especially your substations and critical equipment. Lightning poles near the site perimeter are really helpful to redirect strikes away from critical equipment. Um, we're seeing this added more and more to solar farms to avoid lightning strikes, which really do take a toll on equipment, both immediate disaster, but also slow and steady over time. Ongoing operations, of course, regular monitoring for lightning damage to understand what that looks like. And lightning that doesn't necessarily cause big damage can actually damage your lightning protection system. So making sure your lightning protection system continues to function. This is certainly something the insurance companies are looking at, especially on the wind and solar side. Critical spares for exposed equipment. We're starting to see a trend if there are folks that have portfolios of assets that are distributed of sparing transformers. Certainly turbine components and long lead time items, but transformers are probably the most important from a lightning perspective. And then, of course, regular testing of protection equipment, which is another theme here. Mapping and regular testing seems to be the theme throughout this, our mitigation exercise here. We've seen a lot of protection equipment fail over time. We've also seen instances where it fails because the manufacturer um, had a defect. So paying attention when the manufacturers issue notices, and if there is a protection system recall or something that is troublesome, getting to that sooner as opposed to later is really critically important, especially from an insurance perspective. Excessive heat and drought. On the biomass side of things, adequate feedstock storage areas, making sure that you've got appropriate spacing and setbacks and that there's a process to move piles around if necessary to avoid potential for fire. Certainly having parameters for equipment design, making sure that again, back to making sure that it can withstand the temperatures for which it will be exposed, and that can sometimes include excessive heat. Adequate dust control systems in some places also need to be contemplated, including fire suppression. So fire suppression is also key for any fire or heat related risk. And then, of course, on the ongoing side, monitoring and pile management strategies, that's that spontaneous combustion risk again. Um, Dust management. So if it's dusty and you're processing wood waste near your site or on your site, making sure that there's adequate dust control measures. Record keeping and regular audits just to be able to track it, as the insurance industry is keen on making sure that they can see that you've done everything you can to mitigate losses. In some cases, there are clauses within your insurance policy, although Eric will get to that shortly. And of course, response and contingency planning for extreme weather is key. So if you know there's going to be excessive heat and drought, especially from a personnel perspective, making sure that you have a process in place to avoid any impact there. Now I'm going to turn it over to Eric Howie, and he's going to get into the details of how policies work within the framework of insurance coverage.
Awesome. Thanks, Jen. Okay, so that was a good summary of the different climate risks and mitigations, and now, yeah, let's talk about the basics of the insurance policy and how it can help protect you when you do have a loss. Um, so we'll start pretty basic. Some of this might not be new to you, but just to run through, some of the more fundamental aspects of how the policy works, I think will be helpful. Um, so the first thing I just want to start with here is this risk pyramid. I guess this is kind of a conceptual way of looking at your project risk and how your insurance policy interacts with it. Um, so we've got more frequent risk down here, more severe up here. This first level here is retained risk. So this is the smaller, more frequent losses. These could be minor breakdowns, minor property damage incidents, short duration outages. They're generally something that you can absorb or you can efficiently manage without insurance, so you retain them. This might be the level that your deductibles are set at. And then in the middle, we have larger, less frequent losses. So these are the significant to major events which will materially impact the company if you are to retain them. So these are the ones that companies tend to insure against. These are the losses above deductible and then within your policy limits. And then at the top, you have these catastrophic low probability events. So these might be events that are above your policy limits or events that are uninsurable under a typical policy. Um, and every company's risk appetite and risk tolerance are different. So some may prefer higher deductibles and lower limits because they are comfortable with their risk mitigation measures and and they have the balance sheet to back themselves up. Some companies are risk averse and will prefer to transfer as much risk as they possibly can. And then over here is just a reminder of first party versus third party risk. So first party risk is the risk to your own property and operations. So for example, if your facility burns down, that's a first party property risk. And then third party is the coverage that you carry to defend and indemnify yourself if a third party alleges that you have caused them bodily injury or property damage or some other loss through your negligence or your actions. So we're going to focus mostly on property, this first party bucket today, but we will touch on liability in some of the cases that we've seen that relate to climate. Okay, so again, this is just the basics of a property policy. It's going to cover the cost to repair or replace your property if it suffers a covered loss. Many renewable projects, project owners also buy business interruption coverage, which covers you for the lost revenue when you suffer a covered loss for the duration of your outage. So what is a covered loss? Well, most policies these days are, in Canada at least, are written on an all risks basis, which means that they cover any cause of physical damage except for causes that are specifically excluded in the policy wording. So some key things to be mindful of here are the deductibles. This is how much you pay out of pocket before insurance responds. It could be a flat number or it could be a percentage of the site value. And for your business interruption coverage, it's usually given as a waiting period. And limits and sublimits. So these are the maximum amounts the policy will pay out. So sublimits might be separate lower limits from the main policy limit that are defined for specific perils. So for example, you might have a property policy with a $10 million limit, but a $5 million wildfire sublimit. And then your business interruption coverage will also have a limit based on how much revenue you declare. And then it will have an indemnity period, which is the maximum amount of time it will pay out. And then exclusions. So exclusions are the causes of loss that your policy won't cover. This list can include items that are generally not insurable, as well as items which are usually insured under other types of policies. And it might also include perils that insurers are just not willing to offer cover for. Okay, so what does this all look like in practice? I won't spend too much time on this, but and we will share the slides after this presentation. But this just gives a summary of how a typical wildfire loss might play out. So for example, say, okay, so you've got a 10 megawatt solar farm, wildfire sweeps through the area and destroys half of the panels and inverters, as well as the main power transformer. We're assuming, a site value of $26 million with $1.7 million of annual revenue, wildfire deductible of 3%, and business interruption indemnity period of 12 months, which starts after a 30-day waiting period. So you can see in terms of property damage payout, we look at the loss calculation here. Your property damage coverage will be the loss amount minus the deductible. And so in this case, we have this 3% wildfire deductible that is equal to almost $800,000. So This is something to be mindful of anytime you see a deductible in percent rather than a flat amount. Just take some time to calculate what that is so you have an understanding of how much you're on the hook for. And then business interruption. So this is kind of a basic timeline of the event. So you'll have this 30-day waiting period where there's no coverage. Then you've got um, your insured period here. So in this example, I mean, Jen talked about how transformers can be longer lead time items. So if we have something like an 18-month waiting period to procure and install a new transformer, um, we want to be aware of how long it will take us to get a new transformer so we can calibrate our business interruption indemnity period to that. So if we have an 18-month replacement time on a transformer, but we only have a 12-month indemnity period, then we will have this uninsured 5-month period at the end, where we don't have coverage beyond, our 12-month payout period. So in this case, you can see, this is the uh, business interruption amount. This is your waiting period amount you retain, and this is your uninsured amount at the end. So in this example, you've got $16.4 million of covered losses and $1.6 million of uncovered loss that you retain. So this is just to say, for for your own policy, you want to have a good example or a good understanding of what your deductibles are, your limits are, um, and um, and indemnity periods, and you want to do some scenario planning as well to make sure that you're not retaining more risk than you expect to or than you want to. Okay. Okay, so what is insurable under a typical property policy versus what's not commonly insurable? I think the thing to keep in mind here is that a typical property policy is triggered by physical loss or damage to covered property. Um, so, the typical things that will trigger it, or some of them are listed here. And then your business interruption coverage is triggered when your property damage coverage is triggered. Um, if we look at the list over here, we can see some common causes of loss that don't have a property damage trigger, or they don't cause property damage to covered property, so they won't typically trigger your insurance policy. So one of them that Jen mentioned is lack of resource, so lack of sun, lack of wind, lack of biomass feedstock. Um, Not typically covered under a property policy, but you can sometimes get this coverage as a um, parametric policy or an insurance-backed financial instrument. Sometimes investors look to procure those. Climate mitigation improvements. So your policy won't cover improvements uh, when equipment is repaired or replaced. It will generally just restore it to the condition it was in before the loss. There's some exceptions to that, but that's something to be mindful of. And then lack of access to the site due to flood, fire, etc., and contingent business interruptions. So if something happens to your power buyer and they can't buy power from you, this is going to affect you, but it doesn't trigger your property policy in a typical way. These two items, though, there's usually coverage extensions within your policy, but you just want to make sure that you see those on your policy and that you understand them and look for them. Okay, and just to briefly touch on liability risk. So liability coverage uh, is for the damages and defense costs if someone alleges you have caused them bodily injury or property damage. Um, so, for example, if you start, if it's alleged that your property starts a wildfire, your commercial general liability policy will activate. Um, Insurance company will likely appoint a lawyer to defend you, and then if there's a settlement or damages awarded, um, the coverage is expected to pay that. Um, Similar to a property policy, liability policies have deductibles, coverage limits, and exclusions. things to watch for. So we have seen some liability policies try to exclude uh, things like wildfire. We really like to avoid that, or at the very least, flag it so everybody understands that exclusion is there. But certainly keep an eye out for things like this. And then some positive features, you may be able to get enhanced coverage for some things like forest fire fighting expense. Um, some policies now will afford additional coverage for that. Okay. And how do insurers assess risk? So just mindful that time is ticking on here, but uh, just to quickly run through these. So historical losses, they'll look at losses that you have suffered as well as losses for similar sites and similar technology. Catastrophe mapping, as Jen mentioned, it's a very important feature that insurers review. Risk control measures, we talked a lot about those already. And insurance market conditions will also affect pricing and coverage availability. Okay. Okay, so we've had a look at how policies work now. What is the outlook for climate risk, and how can things change over time? So we just wanted to talk about the typical policy or the typical life cycle of a project in the context of your insurance policies. Um, so let's say you have a wind project with a 20-year power purchase agreement. Here's a hypothetical chart of the policies that you will buy over the course of that project, and then the relative sort of cost of insurance. That's the height of the bars here. So at first you've got a construction policy. This might be held by you or your builder. Um, then after you're done construction, you go to a first year operational policy. This could be placed by you or your builder or a project partner. And then at some point, either maybe a project partner or you are going to be holding the operational policies. And these last 1 year generally. And they're usually the terms are negotiated at the end of the year. And so over the course of a 20-year policy, you've got 20 odd years of policy renewals, and the pricing and coverage can fluctuate over the life of the asset. So many things can affect this: industry losses, project losses. The insurance market fluctuations are going to come into play here, and uh, as well as other factors like the end of equipment warranties and stuff. And then at the end of the project, you may either or the end of the power purchase agreement, you may decommission, you may extend, you may repower. What happens here is going to depend on the project. So how can the actual coverage change over time aside from just pricing? So if we're looking, this presentation is about climate risk, which we expect to fluctuate or get worse generally, right? So if we assume a worsening climate, some things that we may see over time are rising prices, premium increases, especially at vulnerable sites. You may see higher deductibles, and these might be associated with specific perils that are getting worse at the site location or where the risk is increasing. So you may see wildfire deductibles increase, or hail, or what have you. You may see limits or reduced limits for specific perils, similar to higher deductibles. So the sort of amount of coverage is constricting. And in the worst cases, you may see perils just fully excluded. So you may see exclusions for wildfire in California or exclusions for hurricane in Florida, um, in some cases. Um, so, you know, in cases where coverage is no longer available, when it gets to this point, generally, you see people turning to alternative solutions. So things like parametric climate coverage, cat bonds, and government programs. And you may see, risk mitigation measures required by insurers in order to get coverage. So, you may see insurers only choosing to provide hail coverage for tracking systems, and because the risk of a fixed installation is too high for them. And how, how likely is this, and how can one predict it? It's hard to say. I mean, in the near term, the Canadian insurance market is fairly competitive. We aren't seeing a lot of coverage restrictions, this year or last year, um, except in the most vulnerable areas. And we're also seeing that people are building their projects more resiliently. So they're building in the protective features that we like to see. But it's really hard to forecast beyond the near term, right? And let alone for a 20 or 30-year project lifespan. Um, okay, so what can we do about it then? I mean, I think one of the key things is just to budget for resilience and build resilient from day one. So make sure that you're making project choices to build protective design features into the project. With renewables projects, once you build the project, it's very hard to go back and make physical changes. Most of the time, it's not economically feasible. Jen also talked a lot about stocking critical spares. This is key. And then potentially designing to projected climate levels, not just historical data. So there are climate models with specific pathways that will predict how much temperature in an area will rise. You may consider designing to those rather than just current factors. And a common theme we also talked about was developing emergency response plans. This is important for every peril in every facility, and working with your municipality as well. I think that's a good message for this group. They do have resources that they can share with you to help. And then last item, engaging a specialist renewable energy insurance broker. This is uh, this is just something like any broker can place an insurance policy for a renewable energy project, but unless they have expertise in this area, they may not have an idea of what to watch for in terms of policy features and risk management um, uh, procedures. So, um, okay, so I've raced through that. Sorry for going on too long. Aaron, I think we still have a bit of time for Q&A here.